final year BTech student, and this is my Google Summer of Code 2026 project, Rise Farm Agriculture Under Visualization, built for Liquid Galaxy Lab under mentor Vedant and Dev. So this project is a Flutter mobile controller app that visualize India rice agriculture data on the Liquid Galaxy rig. It display colored state boundary KML on Google Earth, show dashboard statistic on the side screen, and provide narrated guided tours across India's rice producing state. This app connects to Liquid Galaxy via SSH and control all the screen from a phone. So this project is built in Flutter with a clean architecture. And now we'll go to the screen and we'll see the complete working of the project. So the project is built in Flutter with a clean architecture. We have controller for SSH settings and LG management, and service handle the KML building, text-to-speech narration and tour playback, and the data layer has 36 Indian state boundary, production statistic, irrigation data and crop cycle information, and all the KMLs are generated dynamically in the app and sent to the Google Earth via SFTP. Now let's open our application, and this is our splash screen firstly, with the project logo and the partner logo. Then we have the home screen with the light and clean UI. So let me first connect to the Liquid Galaxy. First I have to enter the IP address, username, password and number of screens, and once connect, the logo will automatically appear here on the left screen, we can see here. And let me tap to the show production once. So this sends a 36 state heat map KML to the Google Earth, and each state is colored based on the rice production. So basically green for the highest, red for the lowest. And on the right screen you can see the dashboard which show the national production statistics. Now let me go to the major regions. So I can show all the state on the Liquid Galaxy, or tab individual state. Let me fly to West Bengal. So the top right, this is the top rice producer. So the camera will fly to the state, the boundary KML loads with the state highlighted, and the dashboard updates with the West Bengal's statistic. And after 3 seconds the narration begin automatically describing the state rice production. Now next is the seasonal crop feature. So I can toggle between here Kharif or Rabi season. Each season has 4 stages: sowing, transplanting, growth and harvesting. And tapping a stage sends a colored KML, shows the cultivation area. And there is also an autoplay mode that cycles throughout all the stages with the narration. So let's go to the next feature, which is irrigation and rainfall. So the irrigation and rainfall auto loads when you enter the screen, when the user enters the screen, and it show a blue colored KML representing rainfall pattern on the right screen, you can see here. And tapping on state will fly to and show a blue boundary and narrates the rainfall and irrigation statistics. So the dashboard updates for each state. Now let's go to the next feature, which is our guided tour. So we have 3 guided tour here. First we have the India rice belt tour with 7 steps, and then we have the irrigation system tour with the 5 steps, and then we have the seasonal farming tour with the 4 steps. So each tour automatically flies to location, loads KML and narrates the content, so you can pause, skip or stop at any time. So now this is our about page. So here we have all the details about the project, mentors, the data collection, sources, and everything is mentioned here properly. Then the home screen also have the Liquid Galaxy management button, which is show and hide logo, relaunch Google Earth, reboot or shut down all the machines. And we can see here reboot and shut down, ask for the confirmation before executing. And the clean KML button clears all the visualization but keeps the logo. So this was all about my
want you to lift me up so high, high, a place that no one's ever been. Take me to oblivion. Ooh, I wanna feel the dark with you. Ooh, a place that no one's ever been. Take me to Hello everyone, I'm Sona Bhattacharya, and today I will be walking you through the UNESCO World Heritage application that I have built as a part of the Google Summer Poll with Liquid Galaxy. I started this project to bridge the gap between the immersive Liquid Galaxy setup and the interactive Flutter applications. Along the way of the development process, I have learned how to integrate Google's Gemini AI to generate context-aware answers to travel queries and also other user queries. And I've also learned about how to build complex KNNs with multiple coordinates for different sites and create cinematic tours directly into the Google Earth. I have also understood about several development processes and architecture patterns and how we can optimize our applications to create a better experience for the users as well. And the learning process continues with all the challenges and the developments we make in our scale and also the projects we build. So here is the demonstration of the application that I have developed as a part of my GSoC project under Liquid Galaxy. Starting off with the splash screen of the UNESCO World Heritage application, we move on to the search screen first, which shows a list of UNESCO sites having their name, their place, and the category of the UNESCO sites. And we also have a list of state names, which groups the UNESCO sites according to their state. Here, we also have a search bar where you can type your site and also a filter screen where you can select the URL scribe. It can be selected as a range as well as a single value. You can choose the region, you can choose the state names, and you can choose the category. It's a multi-select feature, so you can select more than one here. Next, we move on to the API authentication page where you put in your API keys for Gemini and Google Maps. And next, we move on to the settings screen where I have already put the credentials here. It also has a set of LG commands which get activated when the Liquid Galaxy is connected to the application. Click on to connect LG. It connects the Liquid Galaxy rigs, shows the logos on the leftmost screen, and the LG commands get activated to control the rigs. Next, if we move on to the visualization part, say I choose a site like the George Bank Observatory and I click on Fly to, we can see the site in the form of a 3D PML, the whole visualization along with the balloon that shows the image and the details about this particular site. If you click on orbit, we can see the orbit visualization of this particular site. We also have a choice to stop the orbit when the user wants. We also have few metadatas here and few data about the climate of this particular site as well. Users also get to clear their queries from the Gemini Glide. So when the user has a doubt, we can also ask the Gemini Glide assistant for our queries. For example, if I have a query like when was this site inscribed, we can get the answers to our queries here. We also have an option to hear the response in speech or even speak our queries as well through these buttons instead of typing. But for the demonstration view, we are just typing it here. Uh, Next, we have the color coding of the sites. We use a yellow color for cultural, blue for mixed, and green for natural. For example, if I show you a natural site like this and I click on to fly to, you can see 3D KML is giving color for this particular natural site. So yeah, that's all for the demonstration of this application.
Located in a rural area of northwest England, free from radio interference, Jodrell Bank is one of the world's leading radio astronomy observatories. At the beginning of its use, in 1945, the property housed research on cosmic rays detected by radar echoes. This observatory, which is still in operation, includes several radio telescopes and working buildings, including engineering sheds and the control building. Jodrell Bank has had substantial scientific impact in fields such as the study of meteors and the moon, the discovery of quasars, quantum optics, and the tracking of spacecraft. This exceptional technological ensemble illustrates the transition from traditional optical astronomy to radio astronomy, 1940s to 1960s, which led to radical changes in the understanding of the universe. Speicherstadt and the adjacent Konterhaus district are two densely built urban areas in the center of the port city of Hamburg. Speicherstadt, originally developed on a group of narrow islands in the Elbe River between 1885 and 1927, the architectural, residential and cultural complex of the Radziwill family at Nesvizh is located in central Belarus. The Radziwill dynasty, who built and kept the ensemble from the 16th century until 1939, gave birth to some of the most important personalities.
Hi, my name is Shailesh Kumar Shukla. I am currently pursuing BTech in Computer Science from IMS Engineering College, and I am currently a GSoC 2026 contributor at Liquid Galaxy under the guidance of mentor Victor and mentor Prayag. My project name is LGRPG, a multiplayer 2D game which consists of two modes. First is the zombie survival, where up to four players fight together against zombies and have to survive for 3 minutes. The second mode is zone capture, where two teams fight each other and try to hold the zone on the map. Whichever teams hold the zone for longer duration wins. Now, so far I have implemented the core zombie mode, where player can attack the enemy, enemy can attack the player. Multiplayer zombie mode, multiple player can fight against the zombies and play together in real time. The leaderboard, which display the number of kills done by the player and is going to be displayed on the rightmost screen. The AI cheerleader powered by the Gemini, which listen to the game events and react with voice commentary. This is my folder structure for the LG RPG game. And now let me show you the demo of the game.
Shailesh, Curly 6, 7, and 8 are ready to face the horde.
They must survive 3 minutes with 100 health to claim victory.
Look at them standing together, heartbeats racing before the chaos begins.
Their hearts are steady at 100 health for 18 more seconds.
This is a nightmare. Curly 7 is the last one standing.
Curly, that single survivor, has only 4 health against 25 enemies.
My heart is breaking. The entire squad has fallen in an instant.
It is a total wipeout, Curly, with 4 players at 0 health.
Now, so far, this is the demo, and I want to thank you to Mentor Victor and Mentor Prayag through helping and their guidance, and also thank you to the team Liquid Galaxy. Thank you so much.
Hello, my name is Harsh and my project is Local AI with Gamma by Google. So the project is about an automated assistant server which will help any kind of user to use Liquid Galaxy. So for demonstration, this is my Liquid Galaxy and this is the screen below is the Hermes agent that I'm using on a Raspberry Pi. And the current progress of my project is that I'm able to execute basic Liquid Galaxy commands like relaunch, reload, reboot, power off, connecting to the Liquid Galaxy. And I'm also able to create different kinds of KMLs. Also, there is a support for using voice mode, so you don't have to type anything manually. So, in this video, I will first demonstrate manual commands that I have with my Liquid Galaxy, and then I will also add some of the snippets of the actual testing on real Liquid Galaxy in the Yeda lab. So, let's begin with using some basic commands for the Liquid Galaxy. Hey, can you check if I am connected to the Liquid Galaxy?
So we have given the data, and theoretically the machine will be connecting now. So this is good because we have to connect to start connecting to the Liquid Galaxy. Now, how many screens this Liquid Galaxy has? Answer. 5.
Got it. IP 192.168.1.229. User LG. Password Galaxy.
Connection is successfully. And now we can repeat.
Connected to Liquid
We
Galaxy
can repeat the
successfully.
instruction.
I saved
Yes.
the 5-screen connection details for next time.
So let's try a complicated KML now. Hey, create a tour of the Himalayan mountain ranges in India, but also create some 3D triangles indicating the peaks of the mountains. It must be blue color 3D triangles. So now it has created a tour for the Himalayan mountain ranges with the triangles as I requested. So this is the first peak. And these are some more peaks. So this tour will take some time. Let's try to clear it. Can you clear all the KMLs? So done. That is my demonstration. And after this, I will show you some YEDA lab testing clips. And let's try one last Liquid Galaxy command. Can you power off the Liquid Galaxy? It asks for confirmation because then it cannot switch it on. We have to do that thing manually. So my virtual Liquid Galaxy now is powering off.
We are going to show you some of the demos you wrote on your document and also others that we invented that were very nice. Let's
Okay.
start with this demo.
Yeah, here we have a prompt that says make a pyramid over Hanoi. So
The machine starts thinking.
yeah, it starts thinking, working over.
So he's deploying the pyramid from Hanoi. Hanoi is the city, home city of Trang in Vietnam. And now the Liquid Galaxy is
It's
flying
going to
over us.
Hanoi,
the
and
pyramid.
here's the pyramid over Hanoi. So it's working really good.
More short friendly. Robot. Fíjate, fíjate.
So this is another command that we have made, which is make a cube over Jada. This is Jada is our city of a Liquid Galaxy lab, and as you can see here now, the machine is thinking. It takes some minutes, some seconds. So
It took around 1 minute where it's cleaned the Hanoi thing.
yeah.
It's gonna fly back to Jada. And we have a cube in Jada.
Yes, as you can see here on the screen, we have a cube over Jada. So it works perfectly.
It was very nice. Let's go to the next one. Oh, explain that this is a crazy one.
Okay, so here we tried something a little more hard to do and a little more crazy, but it's to put a Pokemon over a place here in Lleida, in the Plaza del Reloj
I'm gonna move.
de Balafia.
I'm gonna go move away. Yes, we are in Africa.
Okay, now we can see the Pikachu on the screen. But
Oh,
It's-
we're going to Jada, flying to Jada, and to the specific square, and we have Pikachu there.
and it's perfectly centered on the square.
Bring Pikachu. Okay, explain this.
Okay, so this is another command that is more complicated because I put it in Vietnamese to check if the machine can understand. And as you can see here, it already did some thinking here, and it's gonna take some few minutes. This means that put a tree on Hoàn Kiếm Lake in Hanoi in Vietnam. And let's see if it's work. Actually, it's gonna be working very well. So we are flying to Hanoi, Vietnam here. And yes, we see a tree on Hoàn Kiếm Lake, so it works perfectly. Amazing.
Good. Let's go. Let's explain this one because this is a hard one.
Okay, so here we have highlight float zones near Rouen, France. We've taken this example from your documentation. So
We choose another city.
yeah, but we chose another city, and it's already working on it.
Why this is difficult?
This is more difficult because it has to call an API to get all the information and represent it on the screen.
Yes. Comment.
So here we have the flood zones in that city. The first time we tried it, it showed a little off the lines, but now it's really well done.
So this is like what I wanna do for my project. So currently this is like showing us the endangered species, which is the a bird living in Doñana in Spain, and this is like very complicated because it's gonna call the API red list and then render it. Actually, this is what I'm doing right now for weeks, for months. So you can see now the machine is thinking, and because this is quite complicated, so it might have some more time, but yeah, the machine is thinking,
So the
and
machine has to select.
yes, to have
First.
to select the like
Time to explain.
yes, so
The API.
through the API and then select the bird and then select also in the place which is Doñana.
So we can say find a species in Africa or in Korea, but we say specifically Doñana, Spain.
Yeah.
So the machine has to find with the API. So it's a very complicated query.
So now we are flying to the place Doñana, and yeah, as you can see here, so this is the place, and with the image of the duck, which is white-headed duck.
Hello, my name is Mahmoud Mohammed. I'm about to graduate from Faculty of Computer and Information Science in Shams University. Liquid Galaxy is currently working on Ubuntu 16.04.7, which has lost its support from Ubuntu like many years ago. So if it has any issues or vulnerabilities, Ubuntu will not release any patch to fix it. So my project came to solve this problem specifically for security reasons. We need to migrate Liquid Galaxy system from Ubuntu 16.04 to Ubuntu latest time support, which is 26.04. So if it has any issues or vulnerabilities, Ubuntu will release a patch to fix it because it's supported. And also we upgraded Google Earth to the latest version, so it will have better compatibility with KMLs, and it will have all the bugs fixed from the many years ago. What I deliver almost fully working Liquid Galaxy system. You can fly, you can make a tour, you can send the logo and so on. And Liquid Galaxy operates on the master-slave architecture. Like you have only one master, and you have other slaves, and master controls the slave, and you can see that they are synchronized together. Like the end of the screen is the beginning of the another screen. And what is the approach what is my approach to this project? First, I learned the differences between Ubuntu 16.04 and 26.04. What has it changed since then, like in packages, in services, and so on, in network, and I begin to take action and start migration from that. So I can walk through the demo and see how Liquid Galaxy works on Ubuntu 26.04. As you can see here, the machine in the middle is the master machine, and the machine which are on the right and on the left are slaves machine. But let's first make sure it runs on Ubuntu 26.04. So if we can go to the terminal to view the information of the distribution. So we can see here that it's Ubuntu 26.04. So let's go back to full screen. Okay, this is the controller application, Flutter application, which will control the Liquid Galaxy system. I entered my IP address and username and port number and so on, and then click on connect to LG. So you can see here that it goes to Spain, and the problem of the resolution of the logo, because the resolution of the slave itself is so small. So when you have the resolution of the slave is much bigger, it will be correct. So if we can go to home, and we can go to bus stations, you can see here that we go to bus stations. And another good thing that you can control Google Earth through Google Map. So from the features of the application, like you can see, you can go right, you can go to left, and so on. But let's go to bus 539. As you can see here, here is the bus, and here is the KML. Like again, if you have a full resolution of the slave, it will be much better. And we can clean KML and logos, and you can see it's clean now. We can go to big form. Like here is the location that it is in the Google map, and we can go to this form, and you can see here. Okay, yeah, that's it. Thank you for watching, and bye.
Hi, I'm Darpan Bhaviskar, a pre-final year student at IIT Jodhpur, and in my GSoC 2026 project named LG Interactive Onboarding, I'm currently working on the 3D model builder feature, which in briefly is a feature that lets the user to push custom and advanced 3D models onto Liquid Galaxy. And apart from that, I'm working on the curriculum engine, which is a fun and guided tutorial way of using the app and its features for Liquid Galaxy, and the Architecture Explorer, which includes interactive UML diagrams with voice narration to understand the Liquid Galaxy architecture more better. So in the 3D model builder feature, I have included 4 pre-bundled packages, and this package is of KMZ, which contains the model file and the model wrapper file. The model file is a DAE file and the model wrapper is a KML file. So for a note, Google Earth only allows the DAE format for the 3D models, and in particular only the triangulated mesh of the DAE file, the Collada file, gets rendered onto the Google Earth. So now let's select a pre-bundled package of tree here, and a place is already selected on the map here, and in the bottom the user can use this orientation and scale section to change the orientation or scale up or scale down the model as per need, and then push it to the Liquid Galaxy. It will take some time, and it will then do a tour to that location where the model is pointed, and as you can see here, the tree is getting pushed. As you can see here, the tree is here onto the earth. Now let's try with a different model. Now let's take an example of car, and we'll push it to the liquid galaxy, and it will take some time, and then after it will do a tour to that location. As you can see here, the red car model is getting rendered onto this Google Earth.
So, hello everyone, I'm Bhumi Shivhare, a Google Summer of Code contributor with the Liquid Galaxy organization. Today, I'll be demonstrating the current midterm progress of my project, EcoGrid Intelligence, While the project is still under active development, I'd like to walk you through the progress I've made so far. So let's get started with the demonstration. First, let's head over to the settings screen and open the connection panel. I have already entered the required credentials, so I'll simply click on connect. As you can see, the connection is successful and the Liquid Galaxy logo has appeared, confirming that our rig is now connected. Back on the home screen, there's a search bar where you can either search for a region or a specific power plant. To make exploration faster, I've also added quick explore cards. So I'll just select USA. As you can see, the application opens the list of the power plants while the rig automatically flies to the USA. The KML also displays the total number of power plants, their risk distribution, and the top 3 high-risk power plants in that region. You'll also notice the fuel type and risk-based filters at the top. These allows you to quickly filter power plants based on their fuel source or their risk category, making it much easier to explore the data you are interested in. Yeah, so it shows the list of the power plants accordingly. So now let's search for a specific power plant. I'll search for hosting. So as soon as I select it, the Liquid Galaxy rig automatically flies to its exact location. The KML also updates to display the plant's CVS score, its overall risk, along with the individual climate stress factors such as temperature stress, wind stress, and water stress. The sheet also says the same. Now let's take a look at the climate insight section. As you can see, the AI has generated a quick summary of the selected power plant's current climate conditions. Next, I'll open the historical climate trend graph. This lets you visualize how the climate parameters have changed over time. By clicking explain this trend, the AI provides a simple explanation of the observed patterns. Now let's move to the scenario simulation. Here, users can test different climate scenarios and instantly see how the CVS score changes. I'll switch between a few predefined scenarios. As you can see, the CVS updates dynamically. I can also analyze each scenario to get an AI-generated explanation of its impact. So now let's start the orbit feature. As you can see, the Liquid Galaxy rig begins orbiting around the selected power plant, giving us an immersive 360-degree view. Whenever required, I can simply stop the orbit with a single click also. So the application also features an AI chat assistant where users can ask questions about different climate scenarios. For example, I'll ask what would happen if the rainfall drops by 30%. Within seconds, the AI analyzes the scenario and explains its impact on the selected power plant. Now let's move to the infrastructure map. This map displays power plant across the globe and it's implemented with zoom-based clustering. As I zoom in, individual power plants begin to appear, and they are categorized by both their risk level and the fuel type. The same visualization is simultaneously reflected on the Liquid Galaxy rig. Okay, so selecting any power plant instantly displays its name, CVS score, and overall risk. As you can see, it shows the power plants according to its risk type, and it is color coded also. So yeah, it is showing the name, the CVS score, and the overall risk. I'll quickly demonstrate this with another power plant also, as you can see here. So yeah, finally let's head back to the Liquid Galaxy controls from here. I can directly manage the visualization running on the rig. For example, I can clear the KML overlays. As you can see, they are immediately removed from the Liquid Galaxy screens. I can also clear the Liquid Galaxy logo, along with several other visualization controls available in this panel. So that concludes my midterm demonstration of EcoGrid Intelligence. I look forward to building upon this foundation and delivering an even more capable platform by the end of GSoC. Thank you.
Okay, hi Liquid Galaxy. I'll demonstrate all the fixes that I made right now. So let's start the app. Now, one of the first fixes was about the logo part, right? Now, the presumption that I had and an image that I was, imagining was that you have to LG would go to advanced LG controls, and then it would send the logo. It would first set refresh so that you have the 2 second timer of it getting blinked there, and then you would send the logo. But when I had a talk with one of my mentors, Yashraj, he told me that it should happen once an SSH connection is formed. So this is the obvious step, that you would go to LG connection settings and you would connect to LG. And when you connect to LG, the SSH connection is formed and then the logo would be sent. So there it is, right? The logo is sent now, and I have kept in mind of the bezels that the actual LG would have. So I've shifted it towards right. And if you supposedly disconnect it, right, and then connect it again, so the logic is whenever a SSH handshake is formed, right, you would see the logo. Okay, now you go back here. So all right, let's start with a quick tour. Fun places to visit in, say, Atlanta. All right, or okay. So now I've started the tour. The other fix that I've made is with regards to the overlay, right? The image that is being sent on the rightmost screen. Now I've decreased the size of it significantly. I wouldn't say it's too small, you would just see. But I think it would map rightly to what I had seen in the image that I was sent, right? Okay, so I got the places. I would start without the fill, and it starts with the park in Atlanta, which is kind of famous. So
this expansive urban park offers vibrant green spaces and stunning skyline views, perfect for outdoor activities and social gatherings.
So you can see the overlay that's being sent on the rightmost part, right? Now it's pretty visible, it's nice as well, and it doesn't take
An
a lot of
interactive
space.
experience showcasing the history of Coca-Cola with fun exhibits and tastings, making it a lively attraction for visitors.
Well, I can basically increase or decrease the size of that later, right? But this was just to show that it's being sent correctly with a nice size, which would also be
A
appeared
trendy
in
22-mile
LG.
loop of trails and parks that connects various neighborhoods, offering art installations and great spots for food and drinks.
Now let's do a thing. So I've also removed the pause and skip scene because that wasn't working. That's for the future. I mean, it's gonna happen after the midterm. But let's just end the tour. Oh wait. Okay. So end the tour. This works perfectly fine, right? What would happen is that now. Okay, so the overlay that was being sent, that's removed. The whole tour, that is done. Okay, let's go to some historic forts now. I want to show one more thing, right? So this was one of the bugs that was happening, that if you end the tour wasn't the tour got ended basically on the app, but it was still alive on LG, which is now discarded. That logic is discarded, and empty KML is sent to basically overwrite it, right? Now we're going to some historic forts in India. It's fetching the coordinates using Flutter geocoding, and I'll just start the immersive tour real quick. And let's just supposedly say that while the tour is happening, you go back. So now I have the option to return to the tour, right? This was one of those things that also happened, right? And then I return to the tour.
A UNESCO World Heritage Site, the Red Fort is a symbol of India's rich history and Mughal architecture.
All right. So once the first location is done, I would exit again for you to see.
The collection of
I'll exit again, right? So again, I have this thing where I can return to the tour, right? So I go
the
back.
collection of forts in Jaipur, including Amber Fort and Nahargarh Fort.
I'll end the tour now, and then I can save it, and it's all here, and I can redeploy that on LG, and the tour is finished on LG as well. So now you can just move around, right? The overlay is also gone. So yeah, that's about it. These are the fixes that I made. There's some UI changes as well, but yeah, thank you so much.
A UNESCO World Heritage Site, an iconic symbol of Mughal power, perfect for exploring India's imperial history. A magnificent effort blending Hindu and Mughal architecture, offering a glimpse into Rajput grandeur.
Hello, I'm Jan Sanchez. I have been selected for the Google Summer of Code, and I am going to show you my application. We are here in Liquid Galaxy Lab with the Liquid Galaxy, and I'm going to explain to you my application, Liquid Galaxy Time Machine. So Liquid Galaxy Time Machine is a tourism application made to travel landmarks to see their evolution through time. So basically you can see the past, the present, and the future of that specific landmark, and a lot of descriptions and a lot of statistics about that place. Okay, so we're going to show the demo. Here in my application, we can see the splash screen. And the first thing we're going to do is we're going to connect to the Liquid Galaxy. Okay, so we go here to connect. We click connect, and we can see in the Liquid Galaxy that my logo shows up. This is my logo for Liquid Galaxy Time Machine, and we are going to see the main features of my application. So here is the main menu, the timeline. You can see the past, the present, and the future, which you can travel. We're going to United States, and we can see, for example, the Statue of Liberty. Okay, we can see that we have different functions depending on which state you are of the application. Here in present, we're going to go to the travel, basically the flight to, and we can see that it does the flight to on the Statue of Liberty. Okay, so now that it's in here, we're going to do the orbit, which is just basically an orbit around the area. Okay, and the orbit is basically infinite, so if you don't click the stop orbit, it will not stop. So basically if you click the orbit, you can see that now it takes a little while, but you can see that it stops. Okay, so we're going to show the first function from present, which is show the statistics of the landmark, and we can see here that it showed 3 chromiums on the center of the LG and the balloon of the present. Okay, so you can see all of the statistics from the present here. This is the main function. We can see all the images, but we can also see these images. I'm going to eliminate this. So we can see in the past, we can see the same function, but with the past statistics. Okay, for the future features, I don't have a lot of things implemented because I need like APIs for the AI. So the show statistics right now doesn't work because I want to add that here you can generate a future estimation image, and this image that you generate will display on the Liquid Galaxy. Obviously, I didn't do that right now, but these features already work. Okay, we're going to go to the past, and we're going to click compare with present, which is basically here on the Liquid Galaxy. You can see the images of past and present, and here a balloon explaining the past and the present comparison, and a summary of the landmark comparison. Okay, these are the main features right now on the application. So now that we have seen all of this, we're going to go to the settings, and we can see you can change from English to Spanish on all of these that are here, and we can see the LG tools. So basically the LG tools are just commands that you can throw on the Liquid Galaxy, for example, shutdown, relaunch. So we firstly are going to do the relaunch. Okay, and when we see that it works, we're going to go on the code demo. Okay, so we can see the LG is restarting. It does it slow because it's sending the information on not at the same time, so it's better for the relaunch. and we can see that it does relaunch. Okay, so we're gonna go now on the code demo. Okay, so basically here in my computer we can see the code from the application. We're going to explain task by task what is displayed on the Liquid Galaxy. So first we're going to explain the logo KML which is being sent. So first we can see here what is being sent to the LG depending on the screens. Here is the calculation, and here is the commands to authorize all of this on the LG, because it's basically an overlay image. This overlay image is in here in logo KML. We can see the overlay, screen overlay that is being displayed for the logo. So we're gonna go back and we're gonna see the open statistics, which is here, the create statistics HTML, which is basically the browser, the Chromiums, and the balloon. So basically, here is the HTML for this, and in here in the open browser, here is for the Chromiums. Okay, so it's basically to open the Chromiums, basically making the authorization to create the Chromiums in there. Okay, so basically the balloon HTML is in here. This is the balloon HTML, which is being displayed like the stats. These stats are in here in this JSON, which these are all of the information from all of the landmarks. And we can go back here to explain the comparison. So in the comparison, we can see the HTML as well for the Chromiums, and also the Chromiums and the balloon. Okay, so the balloon for it, it's right here. We can see the escape fast stats, which is basically the image, and the summary, which is being displayed in the JSON. Okay, we can see past comparison summary for all of these. This is being stored in here. Okay, so we can go back, and finally we can see all of the clears to clear all of this when the buttons are being pressed to stop all of these KMLs. Okay, so that is basically all for my explanation, and goodbye.
Hello, I'm GSoC. I have been selected for the Google Summer of Code 2026. I'm 21 years old, and I had developed the application GSaurio. GSaurio is an application that will help to learn more about the dinosaurs, because what I show is like how the dinosaurs were, where the fossil was shown, the head. I show comparisons with the humans, how the fossil was, and I show exactly the location where it was found, the period of what the dinosaur is from, and the country, and all this. So now I will go towards the demo of my application. So I will enter, and as you can see, now we can see the splash screen. And if we see on the Liquid Galaxy, we can see that the logo has already descended, because what I did was that the application saved the last configuration, so you don't have to put it. But I will reconnect to assure the connection. And now, as we can see here, I have the main screen of the application. I have different periods of time with different dinosaurs. And we can see I have little subtitles with how many dinosaurs I have in every continent. So I could search, for example, the name of a continent if I wanted. So now I will enter Africa, let's say. And we can see on the Liquid Galaxy that I make a flight towards the continent to see it. Now here I have the list of the dinosaurs. I can search another one. So I have this, but well, I will now go to Lesotho, and as we can see here, I have a map here. Meanwhile, on the Liquid Galaxy, I make a flight towards the country. Now I could enter the dinosaur pushing the marker or by the button. So I will go to the Brachiosaurus consors, and we can see we approach to the equation. Meanwhile, on the right screen, we can see that I send it image of the dinosaur and a camel with the information about the dinosaur. That it have the period, the height, the diet, the length, the weight. And if we see on the application, I have the same information here that what I show on the Galaxy, like the scientific information, the fossil material. And now I have this 4 button that about will send that camels again if it fails, but I will show the comparison. That what this will do is send a chromium across all the 5 screens, showing the comparison of size of a human and a dinosaur. Now, if I go to return back, I will cross all the chromiums and have the rest as I had. So I have the same for, I have the message to say the function was made correctly, and the skeleton will make the same. I will open the 5 chromiums showing the dinosaur skeleton. And finally from here I have a narration that talks,
lived during the
but it's not important right now. So here I have a little side menu that I didn't finish because I don't have the logo here, the information isn't finished, the language I couldn't do it yet for midterm, but now I will go to the settings, and we can see that we have here the control panel with the different options like the reboot, the relaunch, the show hide logo, the clean camels. Are important. When I leave the screen of the dinosaur, the camels disappear. So when I change, they go, they change and makes it better. But now I will make a relaunch that, as we see, it makes a pop-up screen. And when I confirm the action, we can see on the Galaxy that it makes the relaunch. And now we can see that the relaunch was made correctly. And now I will pass to show my code demo. So go here. So to start, let's say I have a little folder here of assets where I store all the audio, the database where I got all the information about the dinosaurs, the images like the logo, the marker, all the photos, or the picture of the dinosaur like the normal, the skeleton or comparison. Then I will explain mostly the most important classes of the application. For example, the connection screen that the connection screen, as I said, what I do is like save the previous configuration and load it once I enter the application, so the user doesn't have to put it and makes the connection automatically. And also I have the option that the button, when I have the connect already connected, that we see we make a reconnect. So other special thing will be the home screen. That what the principal functions is that I load all the database here with the load dinosaur, that I made it when I entered the application, and then I have functions to say the available continents on a selected period of time, and the countries in that continent, and the dinosaurs in the country. Also I have a flight, the select dinosaur country or continent to make a flight to, as we saw, to the continent, country, or dinosaur. But when I push the dinosaur, as we see, I change the screen to the dinosaur detail screen and show the camels. So here I also make the calculation for the detail subtitle with all the dinosaurs. And for the dinosaur detail screen, what I have here, like we have the object already of the dinosaur that we have from the database. We already charge all the information and scientific information, so we can show it on the visual interview. And the important thing here is that is the buttons that I have. For example, the narration, the show comparison, about, and all the. For example, here I have the stop narration that is a button that it doesn't work yet because it doesn't appear. And for that I have the dispose to stop the narration. I have the snack to show that the comparison was correct. As I said here, I have the about to show the about camel, to show the comparison, to show the skeleton, and the narration also have a button that is a return back, as we saw, that it goes back to the it closes the chromiums. And finally, I will show the services, the most important ones, because in this class it's too long because I have many services, but I will divide it on a future. So the most important ones will be the connect to Liquid Galaxy, that creates the connection with the Liquid Galaxy and sends the logo if the connection was correct. Another important thing is the execute, that sends all the command to the Liquid Galaxy. I have two functions to calculate the screens, like the leftmost screen and rightmost screen. So the logos and commands are likewise on the right screen. It doesn't matter how many screens will have the Liquid Galaxy. I have the function of the clean dinosaur name and get existing image to find the correct image from the dinosaur on the folder of images on assets. And also I have the create dinosaur info image, that what this function does is create what we saw of the KML of the information about the dinosaur and sends it to the right screen. Then they have the flight to dinosaur, to continent or country. The continent have the positions predefined, but as I said, they make the flight to that position. And finally, I have the dinosaur marker that I show on the application because it doesn't work yet on the Liquid Galaxy. And we have here the same logo that sends when we push the button or it connects. And the show right screen image is important to show later the dinosaur image that we want to show, because we have the show dinosaur about camel that sends on the right screen the information about the dinosaur that we selected, and then we have the send dinosaur normal overlay that sends the image on the right screen. We have later the last thing that will be the chromiums, like the show skeleton image and comparison that sends the image and calculate the size, the chromiums that the open chromiums that open the chromiums on every screen, and then the update HTML to LG that creates the HTML that we will use on every screen. And this will be everything. So thank you.
Hello, my name is Yasmina Ramadan. I've been selected for Google Summer of Code 2026, and I'm resident student at the Liquid Galaxy Lab Lleida. My project is an engine to show up the historical events in a city. For GSoC 2026, I did it for Lleida, but can be any one cities. Now, I will explain my application here. In the menu, I have 6 sections here. I have categories, connection, tools, settings, about us, and help. I have the connection session to connect the app with Liquid Galaxy, and I also have it on the main page here. I have connection, and here I have connection, and now I'm connected. Here is the logo. In the app, I also have a traffic light here. You can see it. It's in color green. Indicator that turns green whenever the connection is active to go to the main categories page. Then I have points of interest. I have cathedrals and churches, museums, and historical events. We can start with points of interest, for example. We go to send to Liquid Galaxy, and Liquid Galaxy go to the city. with an information in the balloon in English. I have orbit. And stop orbit. And now stop orbit. We have different cities here. For example, this. With the information of this city in the balloon. And the same, we have an orbit. And stop orbit. Then we have museums here. For example, this museum, Museum Diocesa. With the information of the museum. Or museum, or this museum. We have a 4 museum in Lleida. And the same, we have a orbit. And stop orbit. Then we have cathedrals and churches. Seu Bella, sent to Liquid Galaxy. With the information of Seu Bella. And here we have tools. Relaunch, shutdown, reboot, clean, KMLs, clean logos, and show hide logos. We have do, for example, the relaunch. We have a confirmation action, confirm. And the Liquid Galaxy do the relaunch. Now we can explain the coding of the application, a little about the coding of the application. And we can finish. Come here, Oriol. Regarding the app development, I implemented the connection and logo transmission in the connection state here. We have a sent logo. Here, my logo is in KML, logos KML. And here I do send logo. Then I send the balloon from LG service, that is here, with sent balloon. And the balloon appears in the slave 3 in my Liquid Galaxy. I also have another folder, called screens here, which contains the apps view, including the different screens, their layout, colors, and overlay appearance. For example, the tools. I have here the tools. And I development here the colors, the wii appearance, or museums. And in database, I have the information and coordinates of the cities. For example, all the park scientific here, I have the coordinates and the information in the balloon. And that's all. Thank you for listening. Goodbye.